turn. And first of all, congratulations to the organizers and to all of us on the very first Helvetic Ruby. It's yeah, probably a round of applause. So this kind of a historical moment. And I don't want to spoil the party, but I'd like to start with talking about tests, Ruby tests, slow Ruby tests, and how to find the best way to speed them up. I would like to start my talk with a question and to play the game. Why do we need to profile tests at all? For our application code, it's kind of obvious. We want the application to be fast. We want to achieve, higher number of requests per second. We want our users to be happy with its performance. That's worth optimizing, profiling, and so on. But tests, we use them only to, locally or on CI. They're not affect our users, at least directly. So why investing into their performance? And there are multiple reasons for that, actually. And I collected some responses from the community. And I'd like to talk about them first, just to lead us to the idea of why we need this. And that would lead us to the way on how to approach test profiling. So I asked this question, and the very first answer I received was not the most popular one, but pretty interesting, to reduce CI costs. That sounds a bit questionable to me, because, optimization work requires some effort, some investment from the team, so you spend work hours on the test suite instead of building features, and it's questionable whether it's worth it. So I tried to figure out the formula to come up with the answer. Should I optimize for reducing cost or not? Dmitry mentioned that I'm a mathematician, so I like writing formulas in LaTeX. Don't worry, you don't need to understand what's going on here. You can do that in your spare time after I publish the slides. But the idea here is optimizing for the cost reduction, for CI cost reduction, only makes sense if you can make the cost less, like if the reduction is high and the amount of effort for this reduction is low. So the left-hand side is the amount of whatever money, whatever we saved after optimization, and the right-hand side is the amount of money we wasted as for this optimization, which can be expressed in the number of work hours. Just to give you an idea how to use this formula, let's consider an example. Say we target a 20% optimization, so we want to cut the CI build time by 20%. It's test part. And we have on average, we have a 30 minutes build, and we have some pricing here. If we put it into the formula, we have something like this. So number of builds for a given period, say a year, must be much greater than the number of hours spent on this constant we just derived from the values below. If we say we want to spend 2 days on this, that's a minimal amount of time you can spend on test optimization. And 2 days could be enough for 20% performance boost. Trust me, and I will show you how you can achieve this in a minute. But even with 2 days, that means, animations. Okay, that you must have at least 50,000 builds for this period you consider, a year. So it's a lot. So it's a bigger team, it's a lot of development, it's slow builds and so on. So investing time for just reducing CI costs is actually going to be your resulting balance could be actually negative because you waste time of your engineers on that work. However, that doesn't mean that you don't need to optimize tests for reducing CI costs. It's just an indicator of your work. Actually, slower CI builds have other positive impacts on the work of your team. And it's not only about the cost of CI, but the amount of time your developers save by avoiding destruction or by optimizing or shortening their feedback loop. That's the most popular answer, why optimizing tests, to make feedback loop quicker. The feedback loop is what defines our productivity. We can describe our work as a set of actions we perform during the day or hour, whatever, and each action could be later split into this loop operations. We do something, we assess the change, we decide what's going to be done next, and we move on to the next action. The thing is, the longer the assessment part, which includes running tests or running CI, waiting for some feedback from the system, the longer it becomes, the less actions we can perform during a work day, say. And when it becomes significantly long, so it introduced destruction. You know, the famous, it's compiling, let's play games situation. Similar things happening with tests, with CI builds in general. And we need to avoid this. We need to avoid the moment when developers got distracted from their work because they just lose focus, they become less productive, and that's how you lose efficient work days along the timeline. And this problem with slow feedback loop leads to another interesting situation, which also has been highlighted by some of the respondents, that tests become not usable locally. So when tests are so slow, you just don't run them locally. You just push on CI and pray for it to become green. And then you're disappointed when it's red. That happens. But tests become only the tool for verification of your program. It's no longer more than like that, because tests are also useful for refactoring, for debugging, for other work. It's more than just verifying that the code is correct. It's your tool, your everyday tool. And you assume to use them often, locally too. But when they slow, you just stop doing that, and you also lose some productivity. Another thing I'd like to add, which is not that popular, actually just probably one person approached me with this answer, that profiling tests also helps in profiling your production application code. Because when most of your tests still execute the code you push into production, right? So there's some test code, but you run all the things, if you have a decent coverage, of course, all the things that affects your user. And by profiling tests, you may discover performance degradation in your application code. And I have some interesting story recently shared on GitHub, and actually by GitHub engineer to me, that they found they improved the performance of production application after finding some bottleneck in the test suite. And that also a pretty valuable outcome of profiling tests. Finally, to fill the gap, I will put here the answer that probably summarizes all that was said before, that faster tests lead to happier developers. And we, Rubysts especially, very kind of focused on this particular topic in software engineering, because Ruby is for developer happiness, and we should apply the same idea to the code we write. And slow test suites are pretty frequently mentioned as the main thing developer teams would like to improve in their everyday work. And I learned that from working with many Evil Martians clients. What is Evil Martians? And actually, I think it's time to introduce myself. Sorry. Yeah. So my name is Vova, or maybe Vladimir. I used to learn German back in the days, so I'm not sure it's still correct, and especially Swiss version. But anyway, you can approach me. I can understand it. You can find me on GitHub. This is my social network. I work on some projects. I'm sorry. Yeah, I would like to use this laser. Never tried it. You've probably seen some of them. Maybe TestProf, Anycable, and so on. I work for the company called Evil Martians. We are a consultancy focused on developer tools, startups, doing a lot of performance optimization work. And we kind of, I would say, open source driven consultancy. So we publish a lot of our work online in the form of blog posts, videos, and open source tools. Today, our CEO, Irina, is present at the conference. So if you have questions about the company, please don't approach me, approach her. Finally, the last bit I'd like to share about myself. Recently, I published a book on Rails. It's not related to the topic at all, almost, but I want to share one fact almost no one knows. So this is my first book I decided to write, but actually a couple of years ago, I started to outline the book on Rails testing, including a huge part on writing tests that run fast. And that's actually what we're going to talk about today. Maybe someday I will find some time to make it a real project. But right now, I only have this one book. But again, I said that it's not related to test performance, but actually, better architecture leads to faster tests, kind of naturally. We're not going into deep with this topic today. We're going to talk about existing slow test suites and how to approach them. So the idea I would like to share is to demonstrate how to, first of all, profile, not to fix, because that's a different topic, and we don't have 2 talk slots for me today. But actually, the process of finding bottlenecks and tests itself was the rest 15 minutes I have. And just to summarize what's been said in the first part, where we're talking about why optimizing tests, the goal of the profiling test is to find often used things, as we going to see in a minute, to optimize with less effort. And that's to have some balance in the amount of time spent on optimizations and the improvement gained during this optimization work. And if we continue playing this game, this question would probably receive most answers like this. How to profile tests? Oh, we have built-in profiling support in our test framework. Our spec has profile option. Rails got profile option recently too. Similar, works like our specs one. Feel free to use it and fix your slow tests. But unfortunately, that won't help you a lot. The thing is, optimizing the slowest tests usually requires a lot of effort. And we already discussed that. You should always take into account the amount of time you spend for optimization compared to the amount of time you may win or amount of cost you may reduce. And with the slowest test, that doesn't work similarly as optimizing slowest, say, HTTP endpoints in production. That always makes sense because actually, not always. If the endpoint is hit once in a month, you don't need to optimize it either, right? But if it's a common endpoint, you must optimize it anyway because it affects your application behavior. But with tests, fixing the slowest 10 would probably stay unnoticeable because you may have thousands of moderately slow tests, which still contribute to the overall test runtime. Recently, we discussed this problem, a comparison between production and test profiling, which Jason said at his podcast. So I'll redirect you here for digging deeper into this topic because it's about an hour talk about these things. But I want to turn back to the Steven quote from Twitter. Steven, by the way, the creator of our spec. But I'm not sure he's the creator of the profile feature. I don't think so. Maybe it's supposed to edit later. So we must focus on often used things. If we find a way to optimize often used things, we will gain the performance boost for the whole test suite, or big portion of it, instead of optimizing single tests. And to find often used things, we need a tool that is dedicated to this task. And that's how we come up with a test-prof idea, a Ruby test profiler, which I would like to talk about today a bit. So what is test-prof? Test-prof is a specialized profiler. It's kind of test-aware profiler for your Ruby tests. It's kind of single purpose, I would say. It's not only a profiler, although we focus on this part of it today. It's also a toolbox with helpers and other techniques to fix your tests with the least possible amount of refactoring. It was born like 5-6 years ago in production at Evo Martians when we worked on a large monolith, and we had this problem with slow CI runs. And we managed to optimize its performance 4 times in a short period, like from 30 minutes to 8 minutes something. We decided to publish our work, to combine it into a single tool, and that's how test-prof was born. Today, that was like 5 years ago. Today, test-prof is used by many well-known Ruby and Rails projects. You may find even examples of test-prof usage in their open source code bases. And my goal is to make you use test-prof after this conference, and please try it with your code base. And I will help you with that. I will show you the first steps you need to do when you start profiling your test suite. So the test-prof way. So by the way, test-prof is just a Ruby gem. So you start with adding it to your project, and from this point on, you can use all its machinery. And the first step in test profiling is actually trying to profile the test suite as a whole, just as a Ruby program, like without any test-specific stuff, to find some environmental global conditions which affect test performance. And for that task, we actually good with general Ruby profiler, the existing ones. We have stack-prof, we have ruby-prof, we have no new one called Vernier. I'm not sure about the pronunciation. It's probably Vernier. I think it's a city somewhere in Switzerland, actually, with this name. Let me just show you a quick example of how to get started with general profiling with test-prof. Test-prof helps to use these profilers without needing to write any code or doing any configuration. Something like this. You just add a gem to your gem file, and you run your test suite by prepending it with a couple of environment variables. Test stack-prof activates stack-prof profiling. And also, we have this magic sample and variable. This is very important for general profiling. It helps us to subset, just select a random subset of your test suite to analyze global problems. Because if you have thousands of tests running general profilers, first of all, would be slow, and the resulting report would be hard to analyze. It just contains tons of data. So, for example, with stack-prof, it's sampling profiler. So it collects stack trace samples with a given rate. And for the whole test suite, it's just going to be zillions of stack traces, hard to deal with them. But sampling helps to, first of all, limit the scope of the profiling. And then if you run it multiple times and some problems occur in all the samples, they clearly indicate that the problem is global and you can fix it at the configuration level. For example, we can find something like this in our stack-prof results. Logger write. That indicates that you haven't disabled logs in tests. That's the first thing you should do when starting doing test optimization. Just go and disable logs and tests. They're useless. You don't need them, especially writing to file. It takes some amount of time. And surprisingly, for most projects, at least I worked with, this is about the same percentage of improvement after removing logs. It's about 6%. There's some kind of magic number. But that's a very cheap in terms of effort optimization. You just add 2 lines of code, and you get 6% performance boost. That's it. That's the whole idea of efficient test profiling. You need to find such tiny changes that lead to noticeable improvements. And that's one of the examples, kind of canonical example. Continuing with stack-prof, it's especially useful for analyzing collected stack traces as flame graphs. And for that, you can use external tools like SpigScope, presented here. Yeah, even for a sample, the amount of stack traces is huge, so probably sampling less would make sense. But after you get familiarized with the tool, with flame graphs, which is, sorry, flame graphs are necessary for everyone who wants to do some profiling and optimizations. And you can find some root causes for slowness. For example, here we identified that we have sentry capture snapshots in test environment, and for some reason it's really slow during some I/O work. It's actually reading files to extract source code, whatever. You don't need this in test. And you don't need capturing a real exception capture in tests at all. You need to use some abstract implementation like a Rails test reporter. And similarly, I would like to show the new profiler Vernier. It's a next generation profiler. It's still in active development by John Holther and Aaron Patterson. And the good thing about it is that it integrates with Firefox Profiler viewer, and it looks a bit differently to SpeedScope, has different interface and features. Yeah, maybe not that user-friendly, I would say. It's more like a professional tool. But it has additional options. We can add markers, for example, to indicate test start, test end, or some other events. That helps us to orient in our frame graph. I'm not going to wait till the end of this video because the result will be the same. We will still find these IO read lines. It's the same project. But that's the process of analyzing these reports. So general profilers are really good in finding like typical Ruby level problems, not related to the nature of our application, but we deal with tests. And when we deal with tests, the way we write them, the code patterns we use, matters actually most than the Ruby code we write. We need to locate these patterns and to kind of fix them, to refactor them into performance-oriented versions. And here we finally need to use some test-specific profilers. Let's move on to the next step, which I call focus, focusing on what matters most. Well, typically, a large test suite contains like maybe dozens of thousands of tests. And if you take a look at the file structure, they're going to be like, they will reflect your architecture somehow, like models, controllers, requests, and so on. But not every group is equally worth investing time in terms of test profiling. And we need to find some test suite that subsets that would bring us the most benefit again. And over the years, we come up with the hypothesis that tests of a similar kind, say all controller tests, all model tests, have similar problems. And there's a high chance that you can find a fix that could be applied to all of them at once. So you don't need to optimize every single model spec. You can just come up with some fix that will improve them all simultaneously. And for that, we built a profiler called TagProf, which helps you to analyze how much time is consumed by every group of your tests. So if you take a look at the resulting report, it looks like this. So it's just a pie chart. And here we see that, we spent more than half time of our tests run in models and controllers. Everything else consumes less time, especially in individual groups. So knowing that, we may focus only on these large chunks, large groups, and continue our profiling work only within these groups. So model specs take 40% of time. If we optimize them twice, which is achievable, we would optimize the overall test runtime by 20%. Nice, that's good, that's noticeable effect. So we continue within this group, but still, this group also huge. We have 8,000 examples. It's still hard to approach them and like analyze them, the source code, for example, to find the bottlenecks. We need to narrow down the scope further. And for that, we can use another profiler from test-prof called event-prof. It's an instrumentation-driven profiler. So it uses, in Rails, for example, it uses active support instrumentation and can use its events. It has some custom events like factory create. And we can use it to select a smaller subset, a subset of tests that, again, contributes the most to the overall time from this group. Say we want to pick the top 20 slowest test files from the suite to continue working with them. 20 is an approachable number. We actually can check them doing like some eye profiling and find some probably obvious problems with the way we write tests. So EventProf comes with this stamping, I can call it stamping capability, so it can automatically add RSpec tags to your slowest group. So later on, you don't need to keep the list of these slow files. You just use tag filtering and RSpec, and you continue profiling with this group. And here, finally, we can be more specific. So we can profile different aspects of testing. For example, we can profile factories with a couple of profilers that come with test-prof. One of them is Factory Doctor, which identifies test examples that do not require real database calls. And thus you don't need to create real database records and spend some time wasted on that. A typical example is using build tab instead of create when you don't need a real record to be created. So Factory Doctor helps to identify those examples. And we have even a recipe, a tool in the test pro that can fix this automatically, kind of automatically, I would say. Factory Prof is one of the most useful profiler for factories. Helps you to understand the way you use factories, the number of factories used, and how they organized, the hierarchy, the relationships between your factory-created objects. It helps you to identify the problem described here called factory cascades. That's typically that could lead, like fixing cascades could lead up to like 10 times performance boost if you do that carefully. But that's the huge topic, the important one, a huge one. Hopefully we have covered it in our blog post, so I'm not going to waste time on that right now. You feel free to reach out to me later. Finally, the final profile I'd like to share is called RSpec Dissect. It helps you to figure out how much time do you spend in your setup phase of your test. So every time we write tests have 3 phases, usually, or 4 maybe. Setup, action, assessment, and tear down, probably, which is kind of also anti-setup. So RSpec Dissect helps you to see how much time do you stamp for setting up context for the test, for every test, and find the slowest one. And with this data, you may come up with a plan on how to optimize. Usually, LAD and before each code is reused by all or most of the examples in a single file. And recreating this data doesn't make a lot of sense in terms of test. Yeah, we want every test to work with clean version of data, but that's not efficient in terms of time spent on recreating this setup. So we need to come up with a better option. First of all, we can use lazy version of LAT in RSpec and before O instead of before each, but that would lead to different kind of problem. In RSpec, we have a better solution. There are 2 tools just that could spend a lot of time for you, in test time for you. One is let it be, and another one is before O with underscore. These tools are the part of the right-hand side of the test prof ecosystem recipes, which I'm not mentioning yet. You see, the test prof is a huge project. We just covered the right-hand side part and not all of it in terms of profiling, but I hope you got an idea how to approach test. But when you discover the bottleneck, you reach out to the left-hand side part and pick the recipe which fits the problem, which helps you to fix it with least possible effort. So as soon as you finished with this largest chunk, with the scope you identified, and come up with some solution, pick the right recipe, develop some, I would say, like test writing hygiene for further specs, because during this profiling process, you figure out how to write tests in the future, probably add some linters to enforce this new style. You can repeat the process with other parts of the test, or repeat it like every month, every year, or whatever. So do that regularly to avoid having slow tests back. And the thing is with this repetition is that it's kind of boring. You do this, run this profiler and that profiler multiple times, blah, blah, blah. And it's a lot of work. The feedback loop is actually pretty long with profiling. And to reduce it, we recently released an autopilot project. It's not truly autopilot. It's like Tesla autopilot, no auto, no pilot, but helps in driving, or in our case, in profiling tests. It helps you to write scenario in plain Ruby to tell me, say, run sample 5 times, aggregate the results, and show me the most used methods. Write event prof and get the list not of the top 10 slowest, because it's kind of not that very efficient, but give me the list of files that in total contributes to the half of the runtime of this particular group. So it can be 10, 20, whatever. It's usually a small portion of files that's the most slowest and adds to the overall time. So today, TestProf is more than just one gem. We have Autopilot. We have also a MockCA project for making mocks more I would say safe, but that's a different topic. And we will bring more tools for writing better tests and Rails and Ruby project later. So stay tuned and follow us on GitHub. And take care of your tests. And come grab some stickers and find me to ask your tests-related questions after the talk. Thank you.